And our next speaker, beyond being this repeat speaker 4 times now, he's passed the hat trick, he's onto the 4-peat, has been tossed around in the air so much, and it's Aikido. He's being tossed around as part of a Japanese martial art, unless he's a stunt double in a movie and we don't know about that, which would be kind of cool if you were. It'd be very cool. He's been tossed around so much that he should get freaking flyer miles for it. So, everyone, please give a warm welcome to Abhijit.
So today, I'm going to talk about multilingual pipelines. Language in terms of computer language, not in terms of, the entire conversation about English and Spanish. So one of the things that I'm going to start off saying, I'm both an affiliate at Georgetown and I work at AstraZeneca, both of which are in the DC area. Standard disclaimer, this stuff is personal, nothing to do with work. So if anyone's colleague at work, don't fire me. So the reason for this talk is that I think pretty firmly that we are now in a multilingual world as far as data science is concerned. I don't think you can get away with just using one language. You might not use other languages well, but you can't get away with just using one language. And so I think that we are actually in a place where we are polyglots by necessity. And so there's a few ways that I have used multiple languages. Back in the day when, this is 10 years ago, when I got frustrated with R and how long it took to load stuff into R, I used Python to ingest data, which was faster, and then used R for analysis. This was bioconductor stuff. And then R Markdown for reporting. So that started me on this. And this is like way before the days of reticulate or anything. This is just literally Python ingests it, makes it into a form, then I can use R to take it over. Another path that I've used is I've got data on databases, and I use SQL for the munging and extraction, and then R for the analysis. And that can entirely be from R. It could be SQL or separately. I know there's several of you who have sort of come from this sort of background, coming from a database background, and then learning R for other stuff, typically visualization. And the last one is something that I'm actually doing right now. I'll talk about it a little bit later in my talk, but it's using R for the data ingestion and munging. So how far we have come that we went from not using R for data ingestion and munging to using R for data ingestion and munging. And then using both R and Python synergistically in a machine learning pipeline, and then kicking it back out to R and actually say R and Python for visualization, because certain things now, especially with the JavaScript stuff, is better in Python than in R in terms of interfaces. So lots of different ways of doing this. And this is not the limiting thing. I know people who have SAS and are using R on the side from SAS IML. The entire SAS via Python thing is happening. But a lot of stuff from R. So there's a huge R JavaScript thing. There's a huge, obviously, R Python thing going on. So lots of multilingual efforts going on. So part of this is based on use cases, right? And based on where things are. So the data is where it is. I'm not going to pull it out of my SQL database just because I can or need to. A lot of the bioinformatics data sets I work with now are actually distributed as RDS files, or it could be on the web and I have to download it. This is becoming more and more of a use case that the algorithms are available in one language or the other. This is especially true for deep learning kinds of things, which are almost entirely Python based, whereas a lot of the munging, visualization, reporting is R based. And so I'd rather not have to port everything to R to do. I'd rather have a good product where it is. We can now decide which parts we want to make speedy. So certain things are faster in certain languages than others. And even without going to the C++ or Julia or shell routes, there are pieces you can do that will be speedier than others depending on the right tool. And as a aside, I'm not starting a fight with the SAS folks, even though it happens. And I'm avoiding R Java with a 20-foot pole for this talk, and really in everything. R Java's done better, but I'm still not taking it. So And about this talk, I'm not going to talk about just data ingestion. Data ingestion is an old problem. We've sort of figured it out. Data is in different formats. You can either bring it to a common format or just read it natively. Haven is a great one for the SAS folk. We've got all the DBI-based stuff for databases, HGTR for APIs. There's stuff for JSON. There's stuff for Excel. So we've sort of gotten a pretty good handle on this. But really, actually running stuff outside of R, but from R. So R being the controller. That's sort of what I'm interested in here. And so there's a few connections that I use. This isn't by no means exhaustive. This is just the tip of what I tend to use. You guys will probably do a lot more. Actually, the one connection that is not here that I'm increasingly using is with JavaScript. But there's databases, there's Stan. For those of you who don't know that Stan logo, that's that red big dot with the sort of contrasted S in it. Python, of course, the shell, SAS, and there's different directionalities. R and Python tend to be bidirectional. Stan tends to be, I'm using Stan to just bring stuff into R, and so on. But this is sort of my ecosystem that I keep playing with. Like I said, this is, each of you can have your own, and there's all sorts of different players that you can put into this. So I know that people want to go to reticulate because reticulate is cool and fun and so on. But let's hold our horses. Just talk about a little bit about some of the other things that we can use and I use. I'm old, as can be said by the gray hair on my beard. So I still use the shell. And I know there's young people who use the shell too, but I'm going to just say that because I'm old, I keep using the shell. So Mark Weissman, who talked yesterday, and I teach a big data class at Georgetown. And one of the things we've actually talked about a lot is that these kids have to be taught the shell, otherwise we can't teach them big data on Amazon. So shell scripting is still important. And it's available for everyone on every platform now. And I think it's just as important as it has been. But one of the things that shell and all of this stuff is that people forget, even though it's old, it's really efficient because it was developed at a time when there was no compute power. You couldn't just throw, another 2 GPUs at it. So these are really fast and really quick. Not great UIs, but they're quick. And so, everyone knows the shell, the system stuff in R. That's people have used that, I think, more often than not. But the stuff that I actually got excited about last year when I discovered it is that you can actually pipe a shell command into an fread for data table. And so you can do some pre-processing at the shell level before you even put it into R. And it turns out that someone actually benchmarked this and showed that you can actually have something like a 15-fold reduction in memory and 3-fold increase in speed by doing this. For a particular thing, they were just doing a grep, just a search pattern. But this is really, really useful. So for some things, you can certainly do set and awk and things like that, which are fast and just do things well. And you can just do the pre-processing there and keep things lighter in R. And there's a suggestion, I haven't played around with it as much as I should, but there's also GNU Parallel, which can allow some of this shell stuff to be parallelized, which makes things even lighter and faster. So something to just remind ourselves that shell's still around and still good, and it does talk with R quite beautifully, actually. So something to certainly think about. Databases, of course, are a very common thing, but not just for the data side, but we're actually using it to munge, using SQL, but still living in R. So the ODBC world that we have. The cool thing that happened, I think, maybe 5 years ago now, with the dbply and dbplyr package and some other stuff that RStudio did, is that you can do munging in a database using dplyr syntax, which makes it much easier. So I don't have to remember SQL as much as I used to have. So not only can you do dplyr syntax to run stuff in an SQL database, but you can also, using the SQLDF library, use SQL to run stuff in R. So actually, we can really be bilingual here. And I think this is a boon for everyone who's come from SQL and learning R, or have coming from R and having to learn SQL. And I know several people who are making that transition right now in a corporate environment. And the fact that you can be bilingual in this and take it either way I think is fantastic. This is sort of older, not necessarily brand new cutting edge stuff, but I think I use it enough that it's cool. So given time, I decided I had to choose my battles here, and so I'm going after reticulate. And it took me a while to understand why reticulate was named so until I found the picture. So reticulate is another form of Python. I think many of you probably know that, but if you didn't, now you know. So reticulate is a cousin to Anaconda. It's a cousin to Python. So the big thing that reticulate did is it allowed for a persistent Python instance to run alongside R. There's always been like little bits where you can just run something into Python, have it put an output onto your disk, pull it back in, and then next time you do it, it's a new Python session. Reticulate keeps a persistent session on, which means you can ping pong, if you will. You can do something in R, take it to Python, do something in Python, bring it back to R, and so on and so forth. And that is useful in a lot of different things. And I have actually a use case I'll talk about in a little bit that goes to that. Just a side note for those of you who are in Python, I'm getting less and less fond of Conda and more fond of the traditional pip through poetry. Just works better and faster for me. And you can use any of these virtual environments in Reticulate using the use condev or the use virtualenv functions. So really quick use case. I know this is rgov, and I used to be at NIH, which was big part of gov. So I'm going to talk a little bit about bioinformatics, which is sort of 60% of what I do now. So we're looking at things called single-cell RNA sequence analyses. Fancy name. Basically says we have a way of taking a sample, separating out the cells, finding what the genes are in each cell, and trying to figure this out. Because it's bioinformatics, bioconductor is the way people think, so R again. And so things like CRAT, which is more pure R-based than bioconductor, have already been out there. They're beautifully documented. They're very popular. They're widespread. But there's an increased interest in using deep neural networks and variational autoencoders to look at this kind of complex data. And I kid you not, there's literally a deep learning method of the week for single-cell RNA data in Nature, or Nature Genetics, or Data or Nature Methods, or one of those. There's literally one every week. So it's like it's sprouting and mushrooming and doing all sorts of, reproductive things in the ether. And so these methods are leveraging TensorFlow and Torch and Pyro and technologies that are sort of based in Python. And the thing is that both classes of tools, both the R group pipelines and the Python pipelines, are actually quite useful to gain biological insight in different ways. And you sort of wanted to use the Python bits to inform the R bits and vice versa. So one of the things I've been working on for the last year or so is creating a pipeline. The details aren't necessarily important as to what the pieces are, but what is important is that there's pipelines that are running in R and in Python in parallel. They interact, and then they sort of merge at the end to do sort of language agnostic stuff. And without Reticulate, this really can't happen. So this is something that I've been working on for different purposes over the past year, and it's really fascinating to see how well sort of these co-lingual pipelines can be worked out now. So this is sort of what's motivated me for a lot of this. The other piece that motivates me in this sort of multilingual world with R is R Markdown. And so I've become a big believer in polyglot R Markdown. Well, for those of you who didn't know, R Markdown has actually always been polyglot. When Knitr was written, there were chunks available or processors available for over 45 languages, including some shell stuff, some of our competitors in SAS and Stata and the like. But it's always been polyglot. But with Reticulate, you can actually build because Reticulate keeps the Python on as you're doing things. And so I sort of took that to heart early last year, just before we were going to lockdown. I was asked to teach a 3-day workshop in data science with Python. And I wrote the manual, and the manual is written in R Markdown. But there's no R code in it. It's all Python code. This is open. If anyone's interested, I can certainly send the link around. But the fascinating part of being able to do Python, an entire Python book, essentially, using R Markdown instead of doing Jupyter and anything else, was really nice, since I'm an R first kind of person. and this was just really, really nice. And with R Markdown in RStudio, you can do a lot of this sort of multilingual things in RStudio. There's now native support for 6 different kinds of chunks other than R. And so you can do a lot of stuff internally. So there's some stuff that we were just teaching in our visualization class where we're putting D3 into these markdowns to create D3 graphics and the like. So there's a lot of stuff that's, I think, really interesting, and the ecosystem sort of ripe for exploiting this now, between what RStudio has, what Visual Studio Code has, and what the capabilities of R are in terms of packages. So just leaving with some final thoughts, I think we've at a point where we've sort of got the critical mass of connectors, which are now don't have to be jerry-rigged as much. There's actually packages. So reticulate, we've talked about, RCPP, the old nugget. Julia call gets to interact with Julia. R extender works with Rust. R2D3 with D3. There's the entire HTML widgets group of packages that connect with JavaScript. Torch and Keras are R packages that are using reticulate to connect to the Python versions. Altair, I always laugh at, because the R package Altair is a reticulate wrapper around the Python package Altair, which is the wrapper around the JavaScript package Vega Lite. So it's like we're using a 3-step removed package through like 2 translators. So that was sort of fun. And then the reticulate polyglot piece is, I think, something I use a lot, and I think it's something worth thinking about for publishing, because I think the R Markdown, book down, blog down, and ecosystem is a very mature sort of data science and even non-data science environment for publication. And using sort of these knitr engines, you can do stuff that is not just R. You can do a lot of other stuff. So in the interest of time, of course, I'll stop here. Thank you. And I think I end up, bringing up the rear every year, but I still love it. And thanks for your time. Hopefully next we'll see each other in person.